The ampacity of 14/2 NMB cable at 30 degrees Celsius ambient temperature, when used in a general purpose branch circuit connected to a 15 amps breaker, is 15 amps. NMB cable, which stands for non-metallic building wire, is a common type of electrical cable used in residential and light commercial wiring. It consists of 2 or more insulated conductors enclosed in a non-metallic sheath. The 14/2 designation indicates that the cable contains 2 current-carrying conductors plus a ground wire, and that the conductors are 14 American wire gauge, or AUG, in size. Ampacity refers to the maximum amount of electrical current, measured in amps, that a conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including its size, material, insulation type, and the ambient temperature. The National Electrical Code, or NEC, provides tables and guidelines for determining the ampacity of different types of conductors under various conditions. For 14 AWG copper conductors with type NM insulation, which is commonly used in NMB cable, the NEC typically lists an ampacity of 15 amps. However, this ampacity is based on certain standard conditions, including an ambient temperature of 30 degrees Celsius, which is about 86 degrees Fahrenheit. When the ambient temperature is higher than 30 degrees Celsius, the ampacity of the conductor must be derated, meaning that its maximum allowable current carrying capacity is reduced. This is because higher temperatures increase the resistance of the conductor, which in turn generates more heat. If the conductor is allowed to carry its full rated current at a higher ambient temperature, it could overheat and potentially cause a fire. The NEC provides temperature correction factors that are used to adjust the ampacity of conductors for different ambient temperatures. These correction factors are typically expressed as percentages. For example, if the temperature correction factor for a particular ambient temperature is 0.82, then the ampacity of the conductor must be reduced by 18%. In the case of 14/2 NMB cable used in a general-purpose branch circuit connected to a 15 amps breaker, the ampacity is limited by the size of the conductor and the rating of the breaker. A 15 amps breaker is designed to protect the circuit from overcurrents. If the current in the circuit exceeds 15 amps, the breaker will trip, interrupting the flow of electricity. This helps to prevent damage to the wiring and equipment in the circuit, and it also reduces the risk of fire. When selecting the appropriate size of wire for a particular circuit, it is important to consider both the ampacity of the wire and the rating of the breaker. The wire must be large enough to carry the expected load current without overheating, and the breaker must be sized to protect the wire from overcurrents. In general, it is recommended to use a wire size that has an ampacity that is at least equal to the rating of the breaker. For example, if a circuit is protected by a 15 amps breaker, then the wire used in the circuit should have an ampacity of at least 15 amps. In the specific scenario described, where 14/2 NMB cable is used in a general-purpose branch circuit connected to a 15 amps breaker at an ambient temperature of 30 degrees Celsius, the ampacity of the cable is 15 amps. This is because the ampacity of 14 AWG copper conductors with type NM insulation is typically listed as 15 amps under these conditions, and the breaker is also rated at 15 amps. It is important to note that this is a general guideline, and there may be some exceptions depending on the specific application and local electrical codes. It is always recommended to consult with a qualified electrician to ensure that the wiring in your home or business is safe and compliant with all applicable regulations. Here are some additional factors to consider when determining the ampacity of electrical conductors. Firstly, the type of insulation used on the conductor can affect its ampacity. Some types of insulation are better at dissipating heat than others, which allows the conductor to carry more current without overheating. Secondly, the number of conductors bundled together in a cable or conduit can also affect their ampacity. When multiple conductors are bundled together, they can generate more heat than if they were installed separately. As a result, the ampacity of each conductor must be derated to prevent overheating. Thirdly, the environment in which the conductors are installed can also affect their ampacity. For example, Conductors installed in a hot, dry environment will typically have a lower ampacity than conductors installed in a cool, damp environment. Fourthly, the NEC provides tables and guidelines for directing the ampacity of conductors under various conditions. These tables should be consulted whenever the ambient temperature, the number of conductors bundled together, or the environment in which the conductors are installed deviates from the standard conditions. Fifthly, it is important to use the correct size of wire for each circuit in your home or business. Using a wire that is too small can cause it to overheat and potentially start a fire. Using a wire that is too large is generally not a safety hazard, but it can be more expensive. Sixthly, if you are unsure about the correct size of wire to use for a particular circuit, it is always best to consult with a qualified electrician. An electrician can assess your needs and recommend the appropriate size of wire to ensure that your electrical system is safe and compliant with all applicable regulations. Seventhly, it is important to regularly inspect your electrical wiring for any signs of damage or wear. Damaged wiring can be a fire hazard. If you notice any problems with your wiring, such as frayed insulation or loose connections, you should have it repaired by a qualified electrician as soon as possible. Eighthly, never attempt to repair electrical wiring yourself unless you are a qualified electrician. Electrical work can be dangerous, and it is important to take all necessary safety precautions to avoid injury. Ninthly, always turn off the power to the circuit before working on any electrical wiring. This will help to prevent electric shock. Tenthly, use appropriate safety equipment, such as insulated gloves and tools, when working on electrical wiring. 11thly, follow all applicable electrical codes and regulations. These codes and regulations are designed to protect people and property from electrical hazards. 12thly, if you have any questions about electrical safety, consult with a qualified electrician or your local electrical inspector. They can provide you with information and guidance to help you keep your home or business safe from electrical hazards. 13thly, understanding ampacity is crucial for safe and efficient electrical installations. It ensures that wires can handle the intended current without overheating, preventing potential fires and equipment damage. Remember to always consult the NEC and qualified electricians for accurate ampacity ratings and proper wiring practices. 14thly, the 15 amps breaker is chosen to protect the 14 AWG wire from carrying more current than it is designed to handle. This coordination between wire size and breaker rating is fundamental to electrical safety. 15thly, exceeding the ampacity of a wire can lead to insulation breakdown, short circuits, and ultimately fires. Therefore, adherence to ampacity guidelines is non-negotiable. 16thly, ambient temperature significantly impacts ampacity. Higher temperatures reduce the wire's ability to dissipate heat, thus lowering its current carrying capacity. 17thly, temperature correction factors provided by the NEC must be applied when ambient temperatures exceed 30 degrees Celsius to ensure safe operation. 18thly, the type of equipment connected to the circuit also plays a role in determining the required ampacity. High-demand appliances necessitate careful calculation to prevent overloading the circuit. 19thly, voltage drop is another important consideration. Over long distances, voltage drop can reduce the efficiency of electrical equipment and may require larger wire sizes. 20thly, conduit fill, which refers to the number of wires within a conduit, affects heat dissipation and thus influences ampacity. The NEC specifies maximum conduit fill percentages to ensure adequate ventilation. 21stly, regular inspections of electrical systems are vital to identify potential issues such as corroded connections or damaged insulation, which can affect ampacity. 22ndly, grounding is an essential safety measure that provides a path for fault current to return to the source, tripping the breaker and preventing electrical shock. 23rdly, arc fault circuit interrupters, or size, are designed to detect dangerous arcing conditions that can lead to fires. They provide an additional layer of protection beyond standard circuit breakers. 24thly, ground fault circuit interrupters, or GFCIs, protect against electrical shock by detecting ground faults and interrupting the circuit. They are typically required in wet locations such as bathrooms and kitchens. 25thly, surge protectors safeguard sensitive electronic equipment from voltage spikes that can damage or destroy them. 26thly, proper labeling of circuits is essential for safety and troubleshooting. Clear labeling helps to identify the correct breaker for each circuit. 27thly, electrical permits are often required for new installations or modifications to existing electrical systems. Permits ensure that the work is inspected and complies with electrical codes. 28thly, homeowners' insurance may not cover damages caused by electrical fires if the electrical system is not up to code. 29thly, professional electricians have the knowledge and experience to ensure that electrical work is done safely and correctly. 30thly, continuous loads, which operate for 3 hours or more, require special consideration when calculating ampacity. The NEC requires that the branch circuit be rated for at least 125% of the continuous load. 31stly, multi-wire branch circuits share a neutral conductor and require careful balancing of the load to prevent overloading the neutral. 32ndly, the use of aluminum conductors requires different ampacity ratings compared to copper conductors. Aluminum has a lower conductivity than copper and therefore requires larger wire sizes for the same ampacity. 33rdly, the NEC provides specific requirements for the installation of electrical equipment in hazardous locations, such as areas where flammable materials are present. 34thly, electrical safety training is essential for anyone who works with or around electricity. Training provides the knowledge and skills to identify and avoid electrical hazards. 35thly, lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. 36thly, personal protective equipment, or PPE, such as insulated gloves and safety glasses, should be worn when working with electricity. 37thly, emergency procedures should be in place in case of an electrical accident. These procedures should include instructions on how to shut off the power and provide first aid. 38thly, regular safety meetings can help to reinforce electrical safety awareness and promote a safe work environment. 39thly, it is essential to stay up to date on the latest electrical codes and regulations. The NEC is updated every 3 years, and it is important to be aware of any changes that may affect your work. 40thly, many online resources are available to help you learn more about electrical safety. These resources include websites, videos, and training courses. The ampacity of a conductor is a critical factor in electrical safety. By understanding the factors that affect ampacity and following the guidelines provided by the NEC, you can help to ensure that your electrical system is safe and reliable.